That's our coffee?
Yeah, so, and the other thing I've done too, when I started putting the presentation together, 3i Atlas, there's just so much information out there and so much misinformation out there that I put my presentation together, just trying to, go through it and figure out what's there. Sort through the misinformation and what the true information is. So the presentation I have tonight is kind of long. It's got a lot of details. So hopefully you're interested in the details. If not, you can just look at the associated pictures with them. Wait for the next slide. So, but just out of curiosity, how many people have heard of 3i Atlas?
Oh.
Okay. So you probably heard a lot of different things about it, some of it conflicting, and hopefully after the presentation tonight, you'll have gained a little bit of knowledge and taken to take away with you, and be able to distinguish between the noise that's out there going on with it. So I'll go ahead and get started here.
Welcome to the December meeting of the Mount Shasta Stargazers. We are going to review our club activities from last month, go over the upcoming events for the month of December, and talk about Comet 3i Atlas. This is not just another comet. This is a 10 billion-year-old messenger from a planetary system that no longer exists. A fragment that has been wandering the Milky Way since before the Earth was born. If you're like me, you probably felt being overwhelmed by the media sensation surrounding this object. Breathless headlines, wild speculation, even claims that don't survive 5 minutes of scrutiny. Tonight, we are going to cut through all that noise. For our previous star parties, we met at the location marked by the Phoenix Sky Sanctuary pin at the top of the slide. While it worked well for small groups, the site sits atop a small rise with uneven and somewhat rough terrain, which became challenging and potentially hazardous at night when more than a handful of people attended. This month, I moved to a large flat clearing right beside the road. The ground is mostly level, just some small debris we can gradually clean up at each event. There's room for about a dozen vehicles, which will park with headlights facing the road so people can arrive and leave without destroying everyone else's night vision. Setting up and packing telescopes is now much easier in the dark. The clouds were disappearing for the most part, but high humidity led to heavy condensation on our equipment, which cut the night a bit short. Still, we enjoyed excellent views of the Andromeda Galaxy, Pleiades, and Saturn for a few hours. The real highlight, though, was something completely unexpected. We were quietly observing the night sky when Brian suddenly pointed toward Mount Shasta in the west. None of us could believe what we were seeing, truly anomalous objects moving across the sky. Whatever it was seemed to notice us watching. Within moments, they began fading from view, vanishing right before our eyes. Safety security.
That's why.
And I have my witnesses here.
High school planet hearing that started a monthly public event. It will be conducted the first Wednesday of each month, starting at 6 p.m. This should be easy for our club members to remember, since it will be the day after our meeting. Our webpage will be updated to include a link to the site for making reservations under the More menu. There is a nominal $5 charge for each person. Here is a list of the astronomical events for December. We will not be having a star party. Full moon, supermoon, peaks in just a couple nights, don't miss it. Mercury at dawn, best morning views from December 11th to 17th. Meteor showers, if you're under dark skies, look for the Geminids, peak deck 13 to 14. The Ursids, peak deck 22. Winter solstice arrives on December 21st, start of astronomical winter. Now it is time to talk about our mysterious visitor from another star system, Comet 3I, Atlas. But before we do that, let's revisit our anomalous sighting at the star party. Can they be related? Occam's razor is a principle of reasoning that states entities should not be multiplied beyond necessity. In simpler terms, among competing hypotheses that explain the evidence equally well, choose the one that makes the fewest assumptions or is the simplest. Named after 14th century philosopher William of Occam, it's a rule of thumb, not a law, used in science, philosophy, and everyday reasoning to favor simpler, more parsimonious explanations when evidence doesn't clearly distinguish between options. Occam's razor application for our anomalous sighting during the November star party, two competing explanations emerged almost immediately. Complex, alternative hypothesis, a UFO fleet returning to space from their secret base hidden in Mount Shasta. When they detected our telescopes, they activated their cloaking devices, thus disappearing before our very eyes. Simple hypothesis, Occam's razor winner. SpaceX just launched 60 new Starlink satellites a few hours earlier. They were still in a tight orbital formation, stacked at approximately 290 kilometers altitude, and their large, flat solar panels were brightly reflecting sunlight. They disappeared when they entered the shadow of the Earth. Social media communication. YouTube, a popular social media platform, quickly filled with hundreds of videos regarding Comet 3I/Atlas. YouTube creator revenue sharing model replaced the old shorts fund in 2023, 0.01 to 0.10 per 1,000 shorts view. Content providers make their money from clicks and duration, lends itself to attention-grabbing graphics and speculative content. No need for truth, accuracy, social media. Social media thrives on uncertainty and drama. A gap in our understanding of the science becomes fertile ground for speculation. People use the data with their own interpretations to create stories. The stories spread faster than the science because they are more exciting. Which headline will grab your attention? Comet shows unusual outgassing, or comet changes course toward Earth, indicating alien technology, according to Harvard professor. Many of these posts reference a particular Harvard professor. So, exactly who is this Harvard professor? Meet Dr. Avi Loeb, theoretical physicist. Became a Harvard professor in 1993, was tenured in just 3 years, was chair of the department from 2011 to 2020. Loeb is known for entertaining exotic hypotheses, publicly arguing that we should consider all possibilities, including alien origins. With the inundation of social media, most people don't read past the headlines. The social media narrative around 3I/ATLAS is a case study in how science and storytelling intersect. Public fascination with alien probes can draw attention and funding to space science, but it also risks miscommunication. The line between responsible speculation and sensationalism is thin. Scientists like Avi Loeb walk that line deliberately, arguing that we should remain open to all possibilities. Critics argue that entertaining exotic hypotheses without sufficient evidence undermines public trust in science.
How is Avi Loeb viewed by his peers? The majority of astronomers and astrophysicists, including those at Harvard, dismiss Loeb's ET speculations as pathological science driven by media hype rather than rigorous evidence. Critics argue he bypasses peer review, leverages Harvard's prestige for book sales, and conflates anomalies with aliens prematurely, violating Carl Sagan's extraordinary claims require extraordinary evidence principle. This has created a chilling effect, with collaborators distancing themselves to protect careers.
Extracting signal from the noise, given all the smoke and uncertainty of public media, let's get down to the fundamentals. Just the facts, ma'am. Let's cover what we do know. Facts. Data regarding 3 I/Atlas discovered on July 1st, 2025 by Atlas Telescope. In August, NASA conducted a coordinated planning session convening teams from more than 20 missions to mount the fleet-wide campaign to observe 3 I/Atlas, essentially all hands on deck. September-October 2025, peak activity with Mars flyby, data from Perseverance, MRO, MAVEN, STEREO, September 11th to October 2nd, and SOHO, mid-October imaging during solar conjunction. The U.S. government was shut down starting on the 1st of October 2025. NASA contractors were not affected and continued to gather data, although NASA could not make any announcements during the shutdown period. November 2025, IO1 campaign launch, November 27th. Hubble UV spectroscopy, press briefing, November 19th, shares consolidated data from 12 plus assets, emphasizing unprecedented solar system-wide, but not exhaustive coverage. Hubble Space Telescope General Astrophysics, including galaxy evolution, star formation, and high-resolution imaging of distant objects. James Webb Space Telescope, JWST, infrared astronomy to study the early universe, exoplanets, and formation of stars, galaxies. TESS, transiting exoplanet survey satellite, all-sky survey to discover exoplanets via transit photometry, Neil Gehrels Swift Observatory, multi-wavelength, UV, X-ray, gamma ray, observations of cosmic explosions like gamma ray bursts and supernovae, Spherix all-sky infrared spectral survey to probe cosmic inflation, galaxy evolution, and interstellar ices. Perseverance rover sample collection and astrobiology investigations on Mars' Jezero crater. Mars Reconnaissance Orbiter, MRO, high-resolution mapping and monitoring of Mars' surface, atmosphere, and weather. MAVEN, Mars atmosphere and volatile evolution. Study of Mars' upper atmosphere and its escape to space. Europa Clipper, exploration of Jupiter's moon, Europa, to assess habitability en route. Lucy flyby survey of Jupiter's Trojan asteroids to understand solar system origins. Psyche investigation of the metal-rich asteroid 16 Psyche en route. Parker Solar Probe in situ study of the sun's corona and solar wind. Punch polarimeter to unify the corona and heliosphere. Wide field imaging of the sun's corona and heliosphere from multiple vantage points. SOHO, Solar and Heliospheric Observatory. Joint ESA/NASA mission to study the sun's interior, atmosphere, and solar wind. STEREO, Solar Terrestrial Relations Observatory. Stereo imaging of the sun and heliosphere to study coronal mass ejections and space weather. Initial discovery of 3I on July 1st, 2025 by Atlas Chile, El Sos Observatory, Rio Hurtado, Chile, MPCW 68. Enlarged image from the previous slide showing comet motion. This animation shows the extreme hyperbolic trajectory of 3I/ATLAS as it passes through our solar system. This diagram shows the geometry of solar system planets, Lucy spacecraft, and 3I/ATLAS. Overall appearance. The image is a stark grayscale composite against a starry black background, spanning about 11 arc minutes of sky, roughly 1/3 the width of the full moon. The comet appears as a bright, central, fuzzy dot or smudge, circled for emphasis in enhanced versions, resembling a hazy, star-like anomaly with subtle extensions, evoking a distant comet streaking through space. Nucleus. The solid nucleus is not resolved due to the distance and resolution limits. It manifests as the intense core of the central brightening, inferred as the emission source. Cross-reference data from Hubble and JWST estimate its diameter at 0.32 to 5.6 kilometers, 0.2 to 3.5 miles. But Lucy's view offers no new surface details. Coma and tail surrounding the core is a faint fuzzy coma, halo of gas and dust, visible as a soft glow around the nucleus, indicating outgassing of CO2-rich volatiles. To the right, anti-sunward, a subtle tail appears as an elongated smudge of gas and dust streaming under solar radiation pressure, confirming the comet's active, comet-like behavior. Scientific insights. These images aid in 3D reconstruction of the coma by comparing with ground-based data, e.g. from Las Cumbres Observatory, revealing how interstellar dust scatters sunlight differently from solar system comets. They confirm three I/ATLAS's natural origins: a water-poor CO2- dominant dirty snowball billions of years old, without anomalies. The observations required precise spacecraft pointing near the sun, with the body shielding instruments from overheating. Overall appearance, the images depict the comet as a faint smudge or streak of light against a starry Martian night sky backdrop, resembling a hazy, elongated blur or subtle glow in stacked composites. Processed views, e.g. 20 image stacks from Mastcam-Z, show it as a compact, fuzzy white dot moving through the constellation Corona Borealis, evoking a distant, ethereal streak rather than a vivid object due to the comet's faintness and distance. Nucleus. The solid nucleus is not resolved. It appears as the central core of the smudge, inferred from peak brightness. Cross-referenced estimates from Hubble and MRO place its diameter at 0.32 to 5.6 kilometers, 0.2 to 3.5 miles, but Perseverance's ground view offers no new structural details. Coma and tail, a subtle diffuse coma, gas, dust envelope, contributes to the fuzzy halo, with hints of asymmetric outgassing visible in enhanced stacks. No prominent tail is discernible, though the streak suggests anti-sunward dust streaming under solar pressure. Some viral enhancements show a cylindrical artifact, but experts attribute this to long exposure imaging effects, not structure. Scientific insights. Perseverance's images confirm three I/ATLAS's predicted trajectory and comet-like motion across the Martian sky, aiding orbital refinements and contextualizing its CO2-rich, water-poor composition from other missions. As part of NASA's multi-asset campaign, these surface-level views highlight the comet's natural interstellar origins without anomalies, though they spark online speculation, e.g. alien probe theories from Avi Loeb. The nucleus. The comet's solid, icy nucleus itself is not resolved as a distinct, sharp object. It's too small and distant for MAVEN's instrumentation to capture fine structural details like craters or jets directly. Instead, it manifests as the central brightest pixel, a compact, intense white spot at the image's core, representing the peak emission site where outgassing originates. This dot indicates the nucleus's location and activity, surrounded by a diffuse glow from sublimating ices, primarily CO2, and trace water. Based on complementary Hubble data cross-referenced with MAVEN, the nucleus is estimated to be 0.32 to 5.6 kilometers, 0.2 to 3.5 miles in diameter. But in this UV view, it appears as a sub-pixel point source no larger than 1 to 2 pixels across. During the comet's close flyby of Mars on October 3, 2025, at approximately 0.13 astronomical units, or approximately 19 million kilometers from Mars, NASA's MAVEN spacecraft performed dedicated remote sensing observations of the interstellar comet. Key findings from MAVEN, published November 2025, unusually large and asymmetric CO2 coma. MAVEN's imaging ultraviolet spectrograph, IUVS, detected a massive carbon dioxide-dominated coma extending greater than 300,000 kilometers from the nucleus, one of the largest comae ever measured for any comet at that heliocentric distance. The CO2 distribution was strongly asymmetric, with a pronounced sunward neckline structure caused by very rapid sublimation of CO2 ice. Extremely low water production rate, water, H2O, was nearly undetectable in the UV spectra. This confirmed earlier JWST results that 3 I/ATLAS is extraordinarily depleted in water relative to normal solar system comets.
CO2/H2O ratio greater than 100 times higher than typical. No detectable interaction with Mars' atmosphere. Despite the huge coma, the comet passed far enough from Mars that no significant pickup ions or atmospheric perturbations were seen in MAVEN's plasma instruments. SWIA static mag. Bright CO fourth positive emission, strong ultraviolet emission from CO, fourth positive system, dominated the spectrum, making 3I/ATLAS one of the brightest CO sources MAVEN has ever observed. Bottom line, MAVEN's data reinforced that 3I/ATLAS is a CO2 rich, water poor interstellar object with sublimation physics very different from normal comets, essentially acting like a giant block of dry ice hurtling through the inner solar system. Overall appearance. The image depicts the comet as a fuzzy, pixelated white ball against the blackness of space, resembling a diffuse, glowing orb rather than a sharp point source. This low-resolution view, spanning a small field of view, highlights the comet's hazy envelope rather than fine surface details, with the entire scene processed to enhance contrast for the faint target. Nucleus, the solid core. Nucleus is not resolved distinctly due to the pixel scale, but appears as the central bright pixel or compact cluster, inferred as the emission source. Cross-referenced with higher resolution data from Hubble and JWST, scientists estimate the nucleus diameter at 0.32 to 5.6 kilometers, 0.2 to 3.5 miles, providing a key constraint on its size from this vantage. Coma and tail. Surrounding the nucleus is a prominent fuzzy coma, a cloud of dust and gas extending outward, appearing as a soft, irregular halo of scattered bright pixels. This coma, driven by sublimation of CO2-rich ices, shows asymmetric structure with potential sunward extensions or jets of material, though not sharply defined at this resolution. A subtle short tail or elongation trails anti-sunward, indicative of dust and gas streaming away under solar radiation pressure. Overall appearance. The images are stacked into a composite view, showing the comet as a faint, compact blob or smudge, a small diffuse white or grayish point source against the starry background of space. This low-resolution capture, due to distance and the instrument's design for asteroid studies, emphasizes the object's fuzziness rather than sharp details, resembling a hazy, star-like anomaly in processed stacks. Nucleus. The solid nucleus is not resolved individually. It appears as the central core of the blob, inferred from the peak brightness. Complementary data from Hubble and JWST estimate its diameter at 0.32 to 5.6 kilometers, 0.2 to 3.5 miles. But here it's sub-pixel scale, highlighting the emission origin without surface features. Coma and activity. A subtle, faint coma, cloud of gas and dust, surrounds the nucleus, visible as a slight extension or glow around the central spot in the zoomed-in inset. No prominent tail is discernible at this resolution and phase, but the coma indicates early outgassing of CO2-rich volatiles, consistent with the comet's water-poor composition. Scientific insights. These observations were crucial for refining 3I/ATLAS's hyperbolic trajectory, enabling precise targeting by other NASA assets like Lucy and Mars missions. The data reveals the comet's activity at approximately 2.5 astronomical units from the Sun, with the faint coma providing constraints on dust particle sizes and gas production rates. As noted by NASA/JPL, the images underscore the comet's natural, albeit anomalous behavior, behaving like a CO2-dominated dirty snowball from another star system. Overall appearance. The images show the comet as a bright central white dot against a starry streaked black background, processed in colorized white light to enhance visibility. In the stacked composites, it appears as a compact fuzzy globe, resembling a hazy star, due to the low resolution and faintness of the target. The movie sequence reveals subtle motion across frames, with the comet's position shifting against background stars that streak due to the comet's high speed, approximately 130,000 miles per hour, or 209,000 kilometers per hour. Nucleus. The solid nucleus is unresolved, manifesting as the intense central point of brightness within the dot, representing the core emission source. Estimates from cross-reference data, e.g. Hubble, peg its diameter at 0.32 to 5.6 kilometers, 0.2 to 3.5 miles, but Punch views it as a subpixel feature without surface details. coma, and tail. A short faint tail extends to the lower right, anti-sunward, appearing as a subtle elongation or streak of dimmer material, evidence of dust and gas streaming under solar radiation pressure. The coma, gas, dust envelope contributes to the fuzzy halo around the nucleus, showing early outgassing of CO2-rich volatiles. In some frames, Mars briefly photobombs as a brighter blob passing nearby, adding scale context. Scientific insights. These low signal images highlight 3I/ATLAS's activity at approximately 2.5 astronomical units from the sun, confirming its comet-like behavior with a modest halo component, despite its weather for C/2. They aid in trajectory refinement and solar proximity studies, complementing other heliophysics assets like STEREO and SOHO, as noted by NASA/Southwest Research Institute. The observations underscore the comet's natural interstellar origins without anomalous features. Overall appearance. The resulting composite image is a stark black and white or colorized white light view against a dark stellar background, processed to suppress solar glare and enhance faint signals. The comet appears as a subtle central brightening or fuzzy orb, a slight glow or smudge, rather than a sharp object, evoking a dim, ethereal anomaly in the vast emptiness of space. Nucleus. The solid nucleus is not resolved due to the distance and low resolution. It manifests as the intense core of the central brightening, inferred as the primary emission source. Cross-referenced estimates from other missions, e.g. Hubble, place its diameter at 0.32 to 5.6 kilometers, 0.2 to 3.5 miles. But here it's subpixel and indistinct. Coma and tail. A diffuse coma, gas and dust envelope, contributes to the fuzzy halo around the central spot, indicating ongoing outgassing of CO2-rich volatiles post-perihelion. No prominent tail is visible in this faint view, though subtle elongations may hint at residual dust streaming anti-sunward under solar pressure. Scientific insights. These challenging detections confirm 3I/ATLAS's comet-like activity and hyperbolic trajectory as it exits the inner solar system with no anomalous behavior noted. The images complement solar observing data from Stereo and Punch, aiding in modeling the comet's interaction with the heliosphere. As emphasized by NASA, they reinforce the object's natural interstellar origins, a water-poor, CO2-dominant dirty snowball from another star. Overall appearance. The resulting images are spectral composites in near-infrared wavelengths, rendered as a diffuse glowing halo or ethereal cloud against the dark cosmic background, resembling a vast hazy nebula centered on a faint core. The view emphasizes extended emissions rather than a sharp silhouette, with color-coded overlays, e.g. blues and whites for CO2, to denote chemical signatures. Animations from the data show subtle dynamics, like gas expansion, over the observation period. Nucleus. The solid nucleus is not resolved as a distinct object due to the mission's wide field spectral focus. It appears as the central faint or compact source within the coma, inferred from peak spectral intensity. Cross-referenced estimates from Hubble and JWST place its diameter at 0.32 to 5.6 kilometers, 0.2 to 3.5 miles, but SPHEREX highlights water ice signatures originating from this core. Coma and emissions. The standout feature is the extensive CO2 gas coma, spanning at least 348,000 kilometers, 216,000 miles in radius, one of the largest ever measured for a comet at this distance. This appears as a broad, irregular envelope of bright spectral lines, with asymmetric distributions showing sunward concentrations from rapid sublimation. Water ice and bright CO2 emissions dominate the spectra, confirming the water-poor but CO2-rich nature, with trace detections of water vapor. Scientific insights. SPHEREX 3I/ATLAS as a pristine interstellar remnant, likely formed beyond its parent star's CO2 frost line, with a composition distinct from solar system comets, e.g. greater than 100 times higher CO2/H2O ratio. These observations complement JWST's findings, providing constraints on volatile loss and formation environments, and suggest the comet could be up to 7 billion years old if from the Milky Way's thick disk. As noted by NASA/Caltech, the images underscore its natural dirty snowball behavior without anomalies. Overall appearance. The image is a monochromatic grayscale composite colorized in blue hues set against a stark black cosmic backdrop. It spans a small field of view, about 11 arcseconds, showing the comet as a prominent teardrop plume of dust, a fuzzy, elongated bluish haze resembling a comet's head with a tapering tail-like extension. The structure points toward the bottom left direction of motion, evoking a dynamic, ethereal plume against the void. Nucleus. The solid, icy nucleus is not directly resolved due to obscuration by the surrounding dust. It appears as the compact, brightest central region within the cocoon, inferred as the emission source. Hubble's high resolution constrains its diameter to 0.3 to 5.6 kilometers, 0.2 to 3.5 miles, with the most likely size under 1 kilometer, refining earlier ground-based estimates. Coma and dust plume. The defining feature is the asymmetric sunward dust cocoon, formed by jets of gas and dust ejecting from the nucleus due to solar heating. This teardrop envelope, spanning 50 arcseconds, 100,000 kilometers, shows a fan-shaped inner coma brighter on the sun-facing side, with small dust grains, 1 micrometer, ejected at 22 meters per second, and larger ones, 100 micrometers, at approximately 2 meters per second. A faint, broad eastward tail hints at anti-solar streaming. Background stars appear as short, diagonal blue streaks from Hubble's tracking of the comet's rapid motion, 210,000 kilometers per hour. Scientific insights. The image reveals 3 I/ATLAS's early activity, with a dust production rate of approximately 6 kilograms per second for small particles and approximately 60 kilograms per second for large ones. Consistent with solar system comets, but from an interstellar origin, likely billions of years old, accelerated by stellar encounters. The reddish Tholen-like coma suggests organic irradiation, and no anomalous features support its natural dirty snowball nature. Observations, program 17,830 PID Jewett, A trajectory modeling and composition studies, complementing JWST data on its CO2-rich water pore makeup. Overall appearance. The image is a multi-panel near-infrared composite rendered in a vibrant false color palette against a dark cosmic background. The central panel depicts the comet as a bright, ethereal haze or glowing cloud with a compact white core symbolizing the nucleus and surrounding coma, fading outward into concentric rings of red, orange, and blue hues representing different wavelengths and emission intensities. This creates a nebula-like aura, highlighting the comet's diffuse envelope as it outgasses under solar heating. Nucleus. The solid nucleus is not sharply resolved due to the spectral focus. It appears as the intense, white central core within the coma, inferred as the primary source of emissions. Cross-reference data from Hubble and other missions estimate its diameter at 0.32 to 5.6 kilometers, 0.2 to 3.5 miles, but JWST emphasizes its role in driving volatile release. Coma and emissions. The dominant feature is the expansive CO2-dominated coma, a broad, irregular cloud of gas and dust extending far from the core, visualized through spectral gradients, e.g. red for CO2 peaks, blue for cooler outer regions. This reveals asymmetric outgassing with jets of carbon dioxide, water vapor, carbon monoxide, and trace carbonyl sulfide, confirming the comet's water-poor composition, CO2/H2O ratio greater than 100 times higher than typical solar system comets. Scientific insights, JWST's data portrayed 3I/ATLAS as a pristine interstellar dirty snowball, billions of years old and irradiated by cosmic rays, with activity resembling solar system comets, but enriched in frozen CO2 from a formation environment beyond its parent star's water frost line. No anomalous features were detected, supporting natural origins. A preprint of the analysis was released in August 2025, with follow-up observations planned for December 2025 post-perihelion. NASA press briefing on 19th November 2025. Key takeaways: natural comet, not alien tech. 3 I/ATLAS definitely behaves like a comet with an icy nucleus, bright coma, and tail driven by outgassing from solar heating. No technosignatures, e.g. artificial signals or propulsion, detected, explicitly rejecting extraterrestrial artifact theories. No threat to Earth, confirmed safe trajectory, closest approach on December 19th, 2025 at approximately 170 million miles, 1.8 astronomical units. Orbit predictions refined via non-gravitational acceleration data showing no impact risk. Key observations and data highlights. Size and structure. Nucleus estimated at 1.4 to 3.5 kilometers diameter. Hubble, July 21st. Teardrop-shaped dust coma with sunward plumes. JWST, August. Composition and activity. Low water content, approximately 4%. Elevated Phi-Ni ratios and steep brightness surge, 1/R to the power of 7.5, near perihelion on October 30th. Jets and tail, consistent with natural sublimation. Multi-mission insights. High-rise MRO imaged from Mars, October 3rd. Lucy/Psyche provided 3D tail reconstruction. SOHO detected faint signal during solar conjunction. Anomalies explained. Sunward jets and pulses attributed to asymmetric outgassing rotation, not exotic forces. Ongoing science and collaboration. Early stage findings. Full data released by December. Supports UN's IAWN planetary defense exercise. November 27, 2025, January 27, 2026, for tracking fuzzy objects. Public encouraged to observe via telescopes, binoculars in December.
International Asteroid Warning Network, key details of the campaign duration, November 27th, 2025 to January 27th, 2026, observing window open and since 2024. Objectives, improve astrometry, positional accuracy for comets through global observations, test international coordination among observatories, space agencies, e.g. NASA, ESA, and scientists, enhance readiness tracking potential near-Earth objects, NEOs, by addressing challenges like centroid shifts from cometary features. Collect data on the comet's composition, activity, and interstellar origins to advance scientific understanding. Y3I/ATLAS, its hyperbolic orbit, prolonged visibility from Earth, and high scientific interest make it an ideal live test case for defense drills without actual hazard risks. Key contrasts between Loeb and NASA. Interpretation of the data, Loeb's view. Anomalies compound to favor artificiality. Loeb scale, level 4 to 5. Urges open data release for jet spectroscopy to test thrusters versus ICES ahead of December 19, 2025. Earth flyby, NASA's stance. All fit natural comet models, e.g. JPL horizons. Updates incorporate non-gravitational acceleration as outgassing. Briefing focused on no threat, familiar behavior to counter speculation, ignoring anomalies as work in progress for ongoing IAWN campaign. Critics like Jason Wright call Loeb's claims bad faith questions for media attention. Applying Occam's razor to the NASA versus Avi Loeb drama, around 3, I/ATLAS. The competing explanations for what happened in November 2025. The dramatic / conspiracy flavored explanation. Loeb's implied narrative. NASA is deliberately downplaying or suppressing revolutionary evidence that 3I/ATLAS might be alien technology. They held a bland press conference, released only low-resolution fuzzy ball images, blamed a government shutdown for delays, and repeated the "it's just a comet" mantra because they are either A, protecting the public from panic, B, hiding something bigger, or C, too arrogant and bureaucratic to admit they might be wrong about an extraterrestrial artifact. Assumptions required. NASA is willing and able to coordinate a cover-up or suppression of data. Hundreds of astronomers worldwide are complicit or too timid to speak. The shutdown excuse is a convenient lie. The blandness of the press conference itself is evidence of something being hidden. The simple, mundane explanation. NASA did exactly what government science agencies almost always do. They waited for the legal funding freeze to lift, processed the data through the normal, slow pipeline, and then held a straightforward public briefing to say, here's everything we have so far. It still looks like a comet. Nothing in the new images or spectra forced them to change that conclusion, so they didn't. Assumptions required. Bureaucracy is slow. We all know this. Scientists prefer the explanation that fits known physics until compelling evidence forces a change. Standard scientific practice. When new data is consistent with the old interpretation, you don't suddenly declare aliens, Occam's razor verdict. The second explanation wins by a mile. It requires 0 conspiracies, 0 secret agendas, and 0 extraordinary motives. It only requires people and institutions to behave exactly the way they behave 99% of the time, slowly, cautiously, and conservatively. In short, a boring press conference that says still a comet is not evidence of a cover-up. It's evidence that the new pictures looked boring and commentary. Occam's razor says sometimes the simplest answer really is nothing exciting happened.
All right, well. I know that was a lot of information to take in. We got the
Did
speaker
you
on?
take this picture?
Yeah, this one here I took a couple of nights ago.
Cool.
Uh, And that first one that we had too, the one that was in color, that was taken with our club telescope.
Cool.
So. So some of the things I wanted to point out here. Yeah, you can see, the tail formation here. You can see the anti-tail off in this direction here. And if you look closely, you can see the coma of the nucleus just has a very small dot there in the center. You can kind of make it out. And so the coma here are all the gases and dust that are being ejected from the nucleus that rotates about every 19 hours. So, and the stars are streaked here because I was following the motion of the comet. So, I know that was a lot of information, to absorb, and I'm not gonna have a quiz. So I don't know if, hopefully you weren't inundated with too much information, and hopefully you're able to absorb some of the good information and get a better understanding of what's actually going on with the 3i Atlas. Now, they talk about the International Asteroid Warning Network doing the campaign from the end of November through the 27th of January. So I'm actually involved in that, getting observations from my observatory in Shasta Valley. So, that might be something of interest for a future talk here about
That
exactly
would
what
be
we're
a
doing.
Great talk,
So,
please.
yeah, and
Question,
yes,
have they better determined where it's from and where it's headed?
not yet. They just know it came from well, I've got so much information going through my head right now. I don't want to, misremember, but it just came, from a deep part of the galaxy. They're also, I didn't even bring up the wow signal. And that's one of the things that Avi, he was saying, this is coming from the same direction as the wow signal in 1977. But if you're talking in terms of, galactic distances, they weren't anywhere close. But it gets the public's attention. Say we got this wow signal in 1977 that could have been, extraterrestrial life. Then all of a sudden, 50 years later, this comet shows up. There's got to be a correlation there, right? So. Then no questions? Other than,
This is actually still a professor at Merwison.
no, he's, yeah, Harvard professor. No, he's not there anymore. He's actually moved on. He founded a program called the Galileo program, where he's trying to, push his research into extraterrestrial. But I didn't want to mention that here, get into it. But one thing I noted from the NASA briefing, they didn't mention, anybody by name. They just, at the very beginning, they stood up and say, we want to clear the air, let you know that, this is not an extraterrestrial for, this is a normal comet. So that didn't set well with Avi Loeb, so he's, been making the rounds, and he's getting a lot of attention from the media, pushing his ideas. So. Yeah, hopefully the analogy to Occam's razor made sense to you too.
I was just gonna say that, the YouTube, I've watched videos on it on a regular basis, and in the last year or two, it's gotten worse and worse and worse. I guess I've gotten pretty good at detecting fake videos, and I'm guessing it's about half.
Yeah,
Really bad. I mean.
well, there's
It's unbelievable, some of the stuff they put on there. The one I recall that was it just astounded me. They had two women got disappeared in the forest and they found their remains and they thought it was this park ranger and on and on and on. And I thought, well, that's pretty sensational. So I did a Google search for the women's names. And there was no news, no nothing, but there was one of the women's names was on another video on YouTube in Colorado in a different state. The same kind of thing though, they used the same pictures and all that to make another fake video. And so there's people out there that will do anything.
Oh, yeah, no, they're driving for the clicks, I understand some of them make a lot of money.
Because I noticed the comments, a lot of people believe it.
I
I
know,
see that on the comments, the people are believing what they're seeing.
yeah,
It's
and I think
scary.
the advancement of artificial intelligence too, driving a lot of this.
Yeah.
Because you have a lot of information that you can glean. As a matter of fact, for full disclosure, I use artificial intelligence, to put this presentation together, including AI voice. Maybe it didn't sound like it. The voice on all these slides was actually my cloned voice on one of these applications there. So it didn't. It wasn't consistent across the different slides. It sounded like different people, but I tried to get it to sound like me.
Some of the videos now are putting at the very beginning, no AI was used in this video. They tend to be pretty accurate.
Yeah. Yeah, no YouTube anymore. If I'm looking for news, I won't go to YouTube for the news. If I'm looking, how to get to a part on the car I'm working on, then I'll go to YouTube, and it's very helpful.
Exactly.
In that regard.
How-to videos, and then the explorers that go places and look at old stuff.
Yeah.
They tend to be genuine, but a lot of it is just garbage.
Yeah, well, that's where we're at right now. But supposedly YouTube is developing some new algorithms to go through and weed out this artificial intelligence type stuff. As when we quickly went through, all those pictures in the beginning, a lot of those images are artificial AI created. And the scientists that they show on there, you recognize the scientists, but they had nothing to do, with the production of of what you're watching.
I just watched one with Elon Musk, just giving like a personal video, at his desk in his home. And I'm starting to watch it, and then I noticed around his head, there was like a fuzziness right at the edge of his head, and I went, oh my gosh, this is fake.
Yeah.
They're just using.
Yeah, there's a lot of tells,
Yeah,
but AI is getting better every day. It's learning.
It's amazing. I mean, it
It's-
started to do me and watching him
Yeah.
talk, and then I noticed that.
So I don't know where we'll be in
Yeah.
5 or 10 years.
Yeah.
So Nikki had a question?
So like the chemical composition is different than normal comets we see?
Yeah, they said that the carbon dioxide content is 100 times more than terrestrial or solar system comets that we see. But if you think about it, even though a comet in our solar system, revolves, it takes 100,000 years to come back. You think that's a long time. But in terms of the solar system age, that's not a long time. Every time the comet comes by, it loses some of its gases and dust. And as a matter of fact, I've got a theory. My theory is that all comets become asteroids, given enough time. If you think about, 100,000 years, over 1 billion years, it comes by the sun quite often. And every little time it loses some of its material, and eventually it's just got the rocky core. Yeah.
Turns into a rim.
Yeah. But in this case here, if you got 10 billion-year-old comet that's pristine, that's just been traveling across a galaxy, it's got all this original material, and this is the first time it's coming close enough to a sun or to, a heat source, a star, to heat it up to start losing the material. It's it's not surprising that it's different, because it was born in a whole different, part of the galaxy, so. But those are the findings that it's
I think they
rich in
said that
CO2.
this also has a much higher iron to nickel ratio.
Yeah,
A lot.
Yep.
More iron than nickel.
yeah, and again, without knowing precisely where it was born. But I think we're very fortunate that this is the third interstellar object that's been discovered, and we're observing it for a long time now. And even though at perihelion it was behind the sun, we couldn't see it. We have all these spacecraft out there, and they were able to redirect the spacecraft, to get information that they otherwise wouldn't have when it was that near perihelion. And keep in mind, a lot of these cameras, that's why in the beginning I had the primary mission of the asset. That a lot of the cameras weren't designed to image comets. So it's not surprising, you got low resolution images and things like that, but the fact that they were able to redirect the cameras to get these as much information as they've gotten, I think it's my hat's off to
This
NASA.
photo's better than any of the other photos you
Yeah,
that come from.
well, that's because
Yeah,
it's coming closer to the Earth now. But I've seen a couple of YouTube videos showing, other amateurs having photographs like this, and then they compare it with the NASA. They said NASA's got these $1 billion cameras, and they,
That's what's so funny about the whole NASA program that they had. They
Yeah.
couldn't even come up with something like this to show people.
yeah.
They
Well,
just
because
thought it
the
was bizarre.
Well, because the comet was so far away, and they're taking it with a, like a little pocket camera, not a telescope. This is a 12-inch telescope here, so it's a little bit larger. But the fact that none of these instruments were designed to observe a comet like this, but they're able to reassign it and get some data they otherwise wouldn't have, and they're learning quite a bit. So
its mass loss rate is just dependent on what other heat sources it's near as it travels.
yeah,
So it could go a very, very long time without losing any material ultimately until
Yeah.
it comes into contact or
no,
proximity
exactly.
with something else.
It's just frozen in deep space
Right,
until it
that's
gets
just
close to
burn.
the sun.
Yeah.
And so you got the heat, and then you got the, solar radiation, or the solar wind,
Yeah.
pushing material away. Well, there's some estimates, but they're not even sure the size of it yet. But, they're looking at, 1 to maybe 2.5 miles in diameter. But I think they're looking, latest estimates are on the smaller side. So, and you would think too, if you got a spacecraft coming in, why would you make it 2.5 miles in diameter? Should there be easier, ways to come in? So. Okay, and yeah, did you want to?
I just turned my phone off and I realized that what I want to show you is on this phone, so I hope I can get this thing back up. There it goes.
Okay,
I'm gonna ask you something. I have a 4-second video. Can I send it to you and you put it up on the screen?
no, I don't think we can do that from here,
Yes, you can send it to them, though we can't put it up on the screen.
unless you can do it,
Not yet.
Jim.
Okay, well,
Next meeting, we can-
all right.
Yeah, well, if you would have sent it before the meeting, or we can, show it next month or something.
Okay.
But go ahead and, describe what you have.
I'll come back here.
Can you send an email?
I can.
Okay, send it, copy it to JFH
Is that for tonight or for next one?
now.
Oh, yeah,
Okay.
okay. Let's do it. Okay. I'm very impressed by how scientific you guys are. I'm looking into the scientific approach of something that I've been studying for 8 years. And, let's see, where am I gonna get this?
Okay. while they're doing that, I guess we can, yeah, if you got any more, suggestions on the club meetings or what you guys want to do. Yeah,
Next time we want to see a mothership.
Like,
One of your
I already
shows-
showed you a bunch of other ships up there. You already saw them.
Even to the star party, we saw the moon, the rings of Saturn and two planets or two moons.
Yeah.
That was very cool. And then Brian saw a spaceship shoot across the lens when he was looking at Saturn.
I think
Remember?
Yeah, a satellite.
Satellite,
Yeah.
I mean, what are the chances of?
Well, actually, quite,
There's a lot of them
yeah,
out there.
there's a lot of them out there, especially
Looking
when you look through a telescope, you can see the
It's not
smaller,
something you'd see, yeah.
you
it's
see
not
the
something
smaller
you'd see.
satellite.
We saw
That's all I
some
got
shooting
there.
stars. So,
Well, that's right, we saw one really nice,
Yeah.
bright meteor. that we had.
and it, the
Okay.
dipper, the
So,
big dipper was super clear and it was right at the horizon. And it was huge, just was laying, just looked like it was laying right on the horizon.
Yeah.
Wow, it was really cool.
So, where are you doing this then before?
Well, it's from our star party
The
location.
clearing outside of the town.
Phoenix, I think.
Your vehicle's getting.
Speed road. Wrapped around the rear. Yeah, and then, I have trouble with, wig rats eating the wiring on my truck as well, so that would.
Yep.
Why not?
But we don't have an official star party scheduled for this month, but we got about 2 weeks before Atlas is closest to the Earth.
There's no.
Yeah, I mean, no, we could do something. If you want, the thing is, it's gonna be early in the morning, so,
That's
you know, to view it the best,
It's really,
Well-
last night or this morning, I don't know what time it was, but the moon was going down and Orion was starting to get to the point where it was down about 5, 4. I've never done
Yeah.
this way.
I remember getting up at 2 a.m. to see Haley's Comet.
all right, and did you see it?
Yeah,
Congratulations.
yeah. I'm up on Mount Tamalpais.
Yeah. Wow,
Yeah, I'll send it to my patients.
but it's, I've been trying to observe it every morning.
What time is it approximately?
It's high enough, I think around 3:30 in the morning until just about sunrise.
Yeah.
So. But I'm not sure where it'll be in 2 weeks. Maybe it'll be visible in the late evening. So. But, yeah, let me do some calculations and find out. Because it's about 10th magnitude, so we should be able to see it in our telescopes, without too much difficulty. I just remember, Jim, I forgot. Stop the screen share.
You ready for me?
Well, Jim's gonna bring it up on his side.
Okay, well, okay, I'll just start what it is, whew, where do I start? About 8 years ago, I lived on a little farm in LA. And, I discovered something really quite extraordinary. And it's I've been going after it in a metaphysical way. However, it is appearing in the sky and I seem to be an antenna for it. So I moved up here, to study this, to see if I could find it up here too. And you have to follow me up here, or maybe it was here first and found me somewhere. But I've been filming these huge, massive beams of beautiful energies, all different colors. I do have a few stills that I printed. Unfortunately, when I shot these, this is looking at Mount Shasta. It was no moon, so it was really dark, but you can see the mountain behind. This is what I'm talking about, this kind of big beams. Has anybody seen this kind of thing? Have you seen it? And they come in massive colors and they're beautiful. I've got wings. It's something is coming
At night.
at night, and I can call it in. Even if you wanted to do it on astronomy night, it might be interesting to see if you guys can see it. But I have a 4-second clip. I will say that I have it in this natural form. There was no moon. This is the night I actually shot it. So there was a photographer with me that did enhance the contrast so that you can really see. So it's a beam comes out of the mountain that I recognize. It actually has the name Pearl Jam, and I have photos of it in LA, and I'm pretty sure it's that same beam. But then there's something that happened here that I've never seen before in this clip. And well, you'll see it for yourself.
So in LA, what appeared to be its point of origin?
Well, I'm saying it's coming from the east because I would go out in my yard and just call it in. I have millions of pictures of millions.
Yeah.
And it's all across 2 Androids. And I'm willing to turn all this over to scientists.
What was the point of origin here?